Atomic spectrum. When white light is passed through the prism, it gets dispersed into lights of different wavelengths. If these wavelengths are captured on photographic film, the photograph produced is called the spectrum of white light. This spectrum has colors ranging from red at the long wavelength end of the spectrum to violet at the short wavelength end. The separation into colors is similar to what occurs when light travels through water droplets in the air, forming a rainbow. It can be easily seen that this spectrum is a continuous spectrum. That is, the colors are merging into each other. But what do spectrum of light has to do with atomic structure? Well, when atoms are energized, they give off light. For example, when hydrogen gas is energized in an electric discharge tube, it gives off light, which when passed through prism, separates into 4 lines of different wavelengths. The spectrum so obtained is called atomic spectrum of hydrogen. The important thing to note here is that it contains only 4 distinct lines and is not continuous like white light spectrum. Such a spectrum is called line spectrum. Similarly, when sodium atoms are heated, they emit light, which when passed through prism separates into yellow lines. In each of the above spectrum, the radiations are emitted by the source. Thus, they are known as emission spectrum. There exists an opposite phenomenon called absorption spectrum. Let's explain it using sodium. When sodium atoms are placed in the path of white light, they absorb certain wavelengths from it. And when the remaining light is passed through the prism, the spectrum obtained has all the wavelengths except those absorbed by the sodium atoms and is called absorption spectrum of sodium. Comparing the emission-absorption spectrum of sodium, we can see that the wavelengths missing from absorption spectrum are the same which are present in the emission spectrum. This implies that sodium absorbed the radiations which it emitted when it was excited. An absorption spectrum is always followed by a corresponding emission spectrum. That's why the emission spectrum is sometimes referred to as induced spectrum. A very important fact to note here is that an atom of each element displays its own characteristic set of lines in its emission or absorption spectrum. These spectra can serve as fingerprints that allow us to identify different elements present in a sample, even in trace amount.